Hello class, this is my video for week 3 and 4. I spoke with our instructor and he gave me the green light to do a game in HTML5 and JavaScript, and I've chosen the Windows Phone 8 platform to develop this game for. So I just want to show you real fast. I have the emulator running locally on my machine, and here we can see the location emulator. So basically I just chose a random point on the map in Canada. I have no idea where that is or what it's going to give me, but I just want to kind of show you how the GPS will work in the game. Oops. So the name of the game is EFIP. It stands for Everything Falls into Place. It's a simple puzzle game where we have to get all of those red circles to the purple blocks on the map, but in order to do that they have to follow a path, and they have to stay on the path of the blue squares, so they can't travel onto the green. And in order to do that, you have to click any of these 4 buttons up here to move them, and you can only click them once until all of the circles stop moving, and then you can click another one. And the goal is to get the circle to the goal in as few clicks as possible. So just to kind of show you how it functions, I'll go ahead and click around so you can get an idea. So we can move them all down, but notice how this guy over here didn't move. Move back up, and you can only move once they've all stopped moving, so you can't go down and then right real quick. It won't work that way. Another thing to point out, you could see the GPS location. Apparently I clicked into Alberta, Canada, and that is what their state code or postal code is. So I'm going to go ahead and reset the board. Now I've played this a bunch of times, and unfortunately this is the only level that I have, but it can support any level layout that I put in the game. So I'll definitely try to add more to this. This is a project that I think that I'm going to continue to pursue beyond this class, and I might use this as a prototype. So I'm going to go ahead and complete the level in the fewest amount of clicks. And there we have it. So let's go look at some code. So here we can see the basic layout of the project. We have our Windows XAML and just our basic Windows Phone stuff. So we can come over here. I can see the designer for our page, our main page, and all we see is just the black. And down here, oops, can't really see it, but these are text blocks that I have that are displaying the GPS location. I'm actually gathering the GPS information in the Windows portion, the Windows app portion. And we can see that here. I'm using a geoposition from a geolocator, and then I'm using a reverse geocode query to generate a map address using the map API on the Windows Phone. All of these are capabilities that you have to enable in the properties. So if we come down to the capabilities, we could see all kinds of different capabilities of Windows phones in particular. So if I were to do this on any other device, I would have to get the GPS and geolocation much differently. But Windows made it nice and easy for me. So now let's go into the actual JavaScript and HTML. I'm using PhoneGap and Cordova and jQuery Mobile. These are all just APIs that make JavaScript development a lot easier. So here's our main page, our main HTML page, and nothing fancy. All I have here is all of my JavaScript files. I kind of broke them up into a bunch of different files just because that's kind of how I'm used to developing. I've seen a lot of examples where people just put all their code in one giant JavaScript file, and I wasn't a big fan of it. These are the buttons at the top of the screen that you saw that I'm using for the game logic. So now let's go ahead and take a look into the index JavaScript. This is basically the entry JavaScript file that I have, and I also put some helper functions in here that I've used throughout the application. So basically this is just initialization. It's getting the application ready, it's binding events. This is all generated by Cordova. What isn't generated is this bit right here. I'm creating a canvas element, setting up my game class, which I'll show you, and then I'm also setting the update interval for 1000 FPS. I know that sounds a bit crazy, but I figured different devices might support maximum FPS, so if I set it to 1000, then it should cap it at the device's max interval, no matter which device it's on. At least I hope that's what it's doing. And what I'm also doing is calculating the delta time in the update. And the reason why I'm doing that, even though I set the interval, is because I don't trust that the frames will happen in a fixed amount of time, because you never know what's going on the device, how many applications the user will have open. So I still want to calculate delta time to apply to my updates. So now we'll take a look at the game JavaScript file. This is basically the heart of the application. I wrote a game class which basically handles the load, update, and draw of the game itself and has all of the logic. So in the load, I'm just basically setting everything up. I'm using an array of strings to generate my tile map. So if it's a 0, then it's part of the path. If it's a 2, then it's a goal. And then if it's a 1, it's just a regular blocked off tile, which is the green that you saw. And as far as the block placement, I just have an array of 5 blocks. These are also objects that I created, and I'm just setting their position manually. And here I'm just getting the buttons, and I'm capturing their click events in a few functions. The update's pretty simple. Checking if the game is won, and if it is, then we're not going to update any of the game objects. Otherwise, we're going to go ahead and loop through all of them. We'll apply their updates. We'll check to see if they're dead, if they collide with a goal, and if all of them are dead, then we're going to set the game state equal to 1. And you could imagine the game draw is pretty simple. We're just, if the game state is 1, then we're just going to draw a black background, put the text on top, and wait for the user to click reset. Or, depending on the tile, we're going to go ahead and draw out each of the tiles on the map, and then we're going to draw out our blocks. So the block function is a little in depth. Basically, for every block, what I'm doing is I'm checking to see if it's moving. And the check movement is pretty simple. I'm basically just adding the X and Y components of the vector for its velocity, and if it's not 0, then I know that it's either moving on the X, the Y, or both. And so if we're moving, then I'm calculating the old tile based on the previous position and the new tile based on the current position after the update is applied. And depending on the forward velocity of the tile or of the block itself will determine how I'm calculating the stopping logic for the block. So if we're moving to the right, then I want to compare the right side of the moving block as opposed to the bottom left or top. So that's basically what these if checks are doing. Then I'm just calculating tile positions, and I'm seeing what the value is equal to in the strings, and if they're blocked or goal or open, then I handle it respectively. The rest of this is pretty simple. I'm just going to go ahead and jump into some of the other helper things that I've created. So initially, one of the big things that I wrote was a Vector2 math library. So this is basically just a basic Vector2 class with, just basic vector mathematic operations. I'm not even using all of these, but I figured I might, and if I ever want to make a game in the future and I require this functionality, then I'll have it. So basically we have 2 copies of every function. So for example, we have the add vec2, which will modify the first argument of the function, and then we have an add vec2 underscore c. Basically what that's doing is, if I don't want to modify the original, then I'll return a new vector. And so we have add, subtract, multiplication by a scalar value, we have divide by a scalar value, we have the dot product of vectors, we have magnitude, we have the normalization methods. I've also wrote methods to calculate the angle between 2 vectors, and just some helper degree to radian, radian to degrees. This is basically all the math that I wrote. And then here I have a texture 2D class, and all this is basically doing is managing the resource for a texture based on the source. And I'm also allowing functionality to pass in a function pointer so that we can notify someone when the image is loaded. So here's my block class. I originally was using AABBs and bounding boxes to handle the collision, but I realized that it was a bit too complex for a simple task. So what I'm doing is I'm keeping track of its current position, its bottom position, and its right position. And these are what I'm using to calculate the logic for the block stops in the update function in the game file. And then this guy was really helpful. This is a sprite class that I wrote, and basically what it allows you to do is load a texture and define the dimension of frames inside the texture, and it will allow you to draw specific frames within a sprite sheet at a location. So for example, I'll go ahead, I'll show you guys the actual sprite sheet that I'm using. So this is the actual sprite sheet that I'm using, and what I'm able to do is use this one sprite sheet, and I pass in a location on the sprite sheet based on an index. So if I wanted to draw this guy right here, which I do, then the index would be 1 on the X and 0 on the Y, and it would draw it on the context. So the sprite class was especially helpful. And in fact, I can show you how I'm utilizing it down here. So here's my sprite. I have one instance of the texture loaded that I'm using throughout the whole application. So I'm checking to see if it's a block tile, which means that I cannot move onto this tile. Then this is the position on the tile sheet. So index 8 on the X value, and then index 2 on the Y value, and it'll draw that specific tile. at this position, and I can also pass in a width and a height, so I can scale these. And that, for the most part, is it. It was a lot of trial and error. JavaScript is very weird from what I'm used to. The syntax is very loose, and there's really not a whole lot of rules, and it doesn't yell at you for anything. So I'll write up a whole function and I'll try to test it, and it won't give me any errors. It won't tell me anything's wrong. It just won't function, and then I'll have no idea what's going on. So it was a really weird experience, but I'm glad that I, chose to use HTML5 and JavaScript for this project, because the ability to publish games multi-platform is very beneficial in my opinion. I feel like writing an application once is probably the most optimized way of developing applications, and all modern mobile devices support HTML5 and JavaScript, so I think it's definitely technology that I'm going to continue to use in the future, and I hope you guys enjoyed, and I look forward to moving forward. Thanks.